Welcome to video 2. We are on problem 444. So we had just listed different combinations and hopefully you came up with one that would work as well. And so for C, it says put the equation you found in part A together with your equation from 443 and use substitution to solve the system. So your first equation was 2y plus 1x equals 40. Your second equation is y equals 2x. Now, so we're going to use substitution. So since y equals 2x, anytime you see a y, you're going to plug in 2x. So it becomes 2 times 2x plus 1x equals 40. 2 times 2x is 4x. 4x plus 1x is 5x. And then when you have 5x equals 40, divide both sides by 5, and you get x equals 8. If x equals 8, then you're going to plug that in to one of the two equations. I always, choose the easier one. So if x is 8, 2 times 8 is 16. So that means there would be 8 xylophones and 16 yodelers. And you will notice that will match both of the equations. Now let's look at D. In the answer you found to part C, or is the answer you found in part C, a solution to the first equation you wrote, the equation in part A of 443, and how can you check? Is it a solution to the second one? And why is this a solution to a system of equations? So if you plug in what they gave us, so 16 was y, x is 8, so 2 times 16 is 32, plus 8 equals 40. So it does work the first equation. 2 times 8 is 16, so it works the second equation, and it is a solution to the system because it works in both. So 45 says the solution to hills are alive problem can also be represented graphically. On a graph paper, graph the equation you wrote in part A of 443, and the points you listed on the equation may help. What is the shape of this graph? Label your equation or your graph with its equation. Okay, so a couple different ways you could do this. One, you could have gone back to 443 and you could have used these for your ordered pairs. It'd be x comma y, so 20, 10, 40, 0, 0, 20. So you could use these as your ordered pairs. What I did to take us back and review some of chapter 3 stuff is we want to get y by itself, and then we'd have it in y equals mx plus b form, or the slope-intercept form. So you would subtract x from both sides, and you would have 2y equals a negative x plus 40, and then you divide both sides by 2. I know that looks like a 2, but it's just, or an 8, but it's just where I crossed it perfectly. So 2 divided by 2 makes that a y. And then here, if you have a negative x divided by 2, that's a negative 1/2 x, and then 40 divided by 2 is 20. So you begin at 20, and the way I numbered this graph, I went by 1s on the bottom, and then I went by 2s up here, because I knew I needed numbers to get bigger than 20 for the other graph. And so you'll notice if I'm going down 1 over 2, what that's going to look like is it's going down 2, so I need to go over 4 because it needs to be 1/2. And so since the increments are different, I had to graph it differently. Okay, so if you were just going down 1/2, it'd be down half of a spot here and over 2. And so that's still a place on the line, but I don't like to estimate, so I made it go 2/4. Okay, and then the next one, and then I labeled it 2y plus x equals 40. And then it says explain how each point on the graph represents the solution. The x and y that makes the equation work are all solutions. So like I said, you could plug in the ones from 443C, or you could have graphed your equation like that. And now we're going to graph the other equation, and so that was y equals 2x. So it begins at 0, and this time it's going up 2 over 1. And again, my y's are 1 up 2, and my x's go over 1, so it looks like it's just going up 1 over 1 because of the increments. And then I labeled it. Then you'll notice that the intersection of the 2 points, so for D, is 8, 16. And we know that that is a solution and that it's special because it works for both equations. Stay tuned for video 3.